You also see fish burrows in the fossil record, and fossil lungfish burrows have been recognized in a variety of formations. Lungfish have the ability to bury themselves as long as once again, they have some dampness. They can survive for months at a time. So when their pools dry out, they will dig themselves a burrow, and then will remain in that burrow, hopefully not for too long, and then come out again when the water level rises. So these are examples of these lungfish burrows. And if you were saying to me, well, how can you be sure they're lungfish burrows? Sadly, not all of them made it. So in some of these burrows, you actually find the fish remains. So you find the smoking gun or the smoking fish sitting at the end of its burrow. So that's how you know that these are burrows. And these examples are from the Chinle Formation, Triassic of New Mexico, but we have them in Britain as well. And these examples here are from the South Wales, so on the Llyn Peninsula. And you can see these really nice burrows here, well picked out burrows, which are also fish burrows. And you get whole horizons of them. This is an example from Zion National Park with some arrows pointing out where all these lungfish burrows are. And they're literally marking the intervals where conditions dried out. So you have damper conditions where they've got pools, so they don't need to make a burrow. And every time it dries out, you'll get a series of burrows. Another fish fossil that's occasionally recognized in the fossil record is fish fin marks. And so we've got an example here at the top from the Green River Formation, where our friendly fish here, which is Notagonius osculus, and this fish, as it swims along, it's in relatively deep water here, but as it swims along, it's leaving a variety of traces. So it's got the red traces here, which are feeding marks, the yellow traces, which are from these pectoral fins, and then the gray trace here, which is from its caudal fin or its central fin. So it's actually leaving 3 sets of traces as it swims along, browsing for food. Not only do they occur in deep water, so that's in deep lake sediments, but they also occur when things are drying out. So this example here from Gansfontein in the Karoo, we've got these fish fin marks here, and this is because it's almost completely dried out. So it's just a muddy surface here, which we'll return to in a little bit later on in the talk. And this muddy, very shallow water, the fish, actually, it's not deep enough for it to swim without dragging its fin along the bottom. Now, I'm going to put forward that I think this is probably the most beautiful trace that anybody has ever seen. And this trace is basically like a crop circle on the seabed. And I'm sure many of you that are seeing this talk are aware of the crop circles. And this is not made by man. This is not a man-made one. This is made by a fish. So around 20 years ago, they were some divers diving off the coast of Japan. And they found these strange shapes here. And initially they were thought to be a jellyfish, some kind of jellyfish trace. And then somebody said, well, they're so complicated. And they were finding that each one of these little ridges had a little shell on top of it as well. So they realized that it was something more complicated than a jellyfish. So they put some cameras down there. I think they had a couple of divers who lived down there for a couple of days and watched these structures. And they found that it was actually created by a very small pufferfish. So this is the pufferfish here. I think that maybe even be a pufferfish here or something. It's much smaller than the structure itself. So this male pufferfish takes about 10 days swimming around and gradually making this trace. So he uses his body to create the peaks and valleys, forms irregular patterns in the sand, and then decorates the peaks with shell and coral fragments. And then he just waits there and he hopes that a female will come by and say, that is my kind of guy. Look at that lovely structure that he's made. And if she likes it, she'll lay her eggs in the central portion here in the nursery area. And if she doesn't like it and swims off, then it's back to square one and he'll abandon this nest and he'll go off and make another one. So if you go around this Amami Oshima area, offshore Japan, then you're going to find a multitude of these. And the crazy thing was that not only was it a structure that had never been seen before, but the pufferfish itself was a new species to science as well. Right, now we're on to the juicy stuff with some dinosaurs and reptiles. And we're going to start off by the kind of classic dinosaur trace. And I will stand up here just to show you that I actually have a dinosaur footprint on my shirt here. So I'm a big believer in dinosaur footprints. And you can see that these are quite a variety of footprint types here. So these are from Arizona. They're very close to where those crayfish burrows were. These ones here are a family of sauropods. And you can even see little baby tracks in between the parents. And these ones here are from Bolivia. But there's lots of information locked up in these footprints, and you can tell something about the weight from the depth of the track, something about the speed that the animals are moving from the spacing, something about individual behavior. Do they meander as they walk along? Do they walk in a straight line? Do they really know where they're going? And then herding dynamics as well. So what do they do with do the babies go in the middle? Do they make the babies walk on the outside? Do the juveniles go romping around the edges here while the adults are in the middle? And you can use all of this information. One thing you have to be careful of is that we don't know whether this track and this track were made the same day or the same month or even the same year. So you have to be a bit cautious because tracks can last for a long time. So it's one thing that you might look at is the edges of the tracks to see whether there's any degradation to get an idea how old they are. Now, those are the perfect tracks. And this one down here in the middle from Colorado, these are the really beautiful tracks. These ones are actually, they're not really this color. They use a charcoal wash to color them in to make them more visible. But these are lovely tracks. So that's great that there's these beautiful tracks, but there are also tracks which are much harder to see. And this is an example here. Both these examples are from eastern Alberta. And you can see they're about 75 million years old. And these are, I believe, are dinosaur tracks. And these are sort of trample zones. And there's another trample zone in here. So this is what's known as dinotubation. So it's biotubation, but from dinosaurs. And it can be a little difficult to differentiate. So you have to be a little bit careful with these. But I certainly believe that these structures are dinosaur footprints. And what happens is that the dinosaur makes the footprint, makes a depression into the soil that fills up with a little bit of organic material. And organic material is a great nucleus for cementation. So once you've got this depression here, with the organic material there, then the siderite, the ironstone cementation starts cementing up and actually helps to preserve the trackways. This is my daughter a few years ago, just being a scale here for a really beautiful sauropod footprint. Once again, you might look at this and think this was just a scour. So you have to have a kind of open mind to knowing what these are actually, whether they're traces or not. These are some other less normal traces. So I don't have a fossil example of this, but they do exist, where you have slip faces, where you have the face of a dune, a dipping face of a dune, and an animal's walked across it. This is probably a deer that's walked across here. And every step it takes, it slips down the dune. I'm sure we've all been familiar with walking across sand dunes and slipping down, and it leaves these kind of slip face traces, which are totally different to a normal footprint. So if you saw these in the fossil record, I think it would take a bit of a conceptual leap to believe that they were actually traces. And you might track this out and see where this goes into the flat. So on the flat, you might see better footprints. And then as you get to the slope, you'll see these footprints start turning into slip marks. Other examples of unusual traces. This is a footprint here from a sauropod, so a long-necked dinosaur. And it's actually got scratch marks on the side here. So these were the dinosaur's toenails that made these scratch marks as it was putting its feet into the sediment. And this example here is from Yorkshire, from the Yorkshire coast, around Saltwick. We also have a situation where in the Karoo, so this is where our fish fin marks came from as well. And this is a large herbivore that's walking across, probably Bradysaurus, sort of amphibian that's walking across this dried out area. And it's all right here, the sediment's silty, and so there's not much material getting stuck to his or her feet. But then he's gone into a muddy area. And you know what happens when you walk in mud in your Wellingtons? Your Wellingtons start off as a size 10. And after you've taken a few steps, they turn into a size 24 because you're getting all of the mud stuck to your shoes. So what's happened here is you end up with a squelch print, which is, this is the same footprint as here, but this is with a large vertebrate that's basically got a lot of mud stuck to its feet as well. So that you once again, you have to have an open mind to look for different kinds of examples of traces from the same animal. I'm not really going to talk much about tooth and claw marks, but if you do ever find fossil bones, it's always worth looking at the surface to see whether there's something that's gnawed on them. And this is just a tooth mark on a hadrosaur bone, so that some predator has obviously been trying to feed on that bone. Another trace fossil, and people aren't usually aware that nests count as trace fossils, but dinosaur nests have been identified in China, Alberta, France, many parts of the world, and different dinosaurs lay their eggs in different patterns. So some dinosaurs lay them in spirals, some lay them in circles, like this example here from an oviraptor, and then some of them make a proper nest, Some of them just scrape a hole in the ground. So you can kind of look and see from the types of nests and the types of fossils what type of dinosaur it might have been. And this example here, this is an egg from Aix-en-Provence, so in southern France. And you can see that compared to this type of nest, this is much harder to make out. So you may have more trouble recognizing the nest than you expect. But once you find a piece of dinosaur eggshell, look around to see whether there's a chance of finding the nesting material as well. Now, I've got this a bit back to front, but I was going to talk about these structures as well. And these structures here were found in Utah, and it's believed that these represent a lek. Now, a lek is an open area where grouse go and perform for the ladies. So the grouse will strut its way to the lek, and it will kind of scrape with its foot on the ground and try and show that it's the boss of the roost. And then hopefully the ladies will be interested. And these marks here, these are believed to be scratch marks from a predatory dinosaur, from a theropod dinosaur, so bottom left here. And these are just different examples that are sitting there. And this is a very well-known ichnologist and paleontologist who's sitting by his finds here. So this is how these have been interpreted. So this is an ancient dinosaurian lek, L-E-K. So it was always thought that dinosaurs are too big to really live in burrows until a geologist called, he's actually an ichnologist as well, called Anthony Martin, discovered a new type of dinosaur, Oryctodromeus, and these were found inside a burrow. So it's all very well finding burrows, as we mentioned earlier, but if you can find the animal, the maker in the burrow, the smoking gun in the burrow, then that really confirms that what these are. So these two fossils here, these are two dinosaur burrows that were discovered in Montana, and they contained fossils of this particular dinosaur, which was also a new species. So once again, that's all very well when you find the dinosaur in there, but there are many other burrows which do not have the animal preserved, and you might not recognize them as being mammalian or reptilian burrows. So quite often you find them, you think, well, is this a burrow or is this a footprint? You're not quite sure. So you need to have an open mind, because I think there's many, many, many burrows out there. They're much more common than we realize. But if you find an odd piece of one, like a concretion like this, like B sitting there, then you're going to struggle to think to yourself, well, that's probably a vertebrate burrow. So there's many more out there than we realize. I just put this in. This is not, it's in the reptile section, but I wanted to mention it because these burrows that were found are really quite extraordinary. So these are some of the largest burrows in the world. And they were only discovered in around 2010. And they dug a few of them out. And you can see how enormous these burrows are. They're bigger than a person. And it was initially, they were really unsure what had happened. They thought they might be fossil man or something like that. And then they started finding these scratch marks. And these scratch marks tie in to fossil glyptodons. So these were glyptodon burrows. So these glyptodons were basically behaving like modern armadillos, and armadillos, they make their own burrows as well. So these were like giant armadillo burrows. And I just wanted to mention that, because I'm talking dominantly to British attendees today, is that the glyptodon was named by Richard Owen. So before he managed to name the dinosaurs and then coin the word dinosaur, he was concentrating on glyptodons. So 1839 was when he gave the glyptodons their names. Another something that we see in the modern record is snake traces. And I've got two types of snake traces here. This is something you see on a lot of nature programs in the desert, the sidewinder, where it wants to have as little of its body on the sand surface as possible to try and stay cool. And you end up with not a kind of like a snaking trace, but these weird parallel lines. Once again, this is something we should be looking for in the fossil record. If we saw it, I wonder whether we'd think maybe it was ripples or something like that. I think we'd struggle to realize that this was a snake trace fossil. And then this is another snake trace here that we came across in Oman while we were driving along. And I said, stop the vehicle. And I jumped out and got some pictures of this, this snake trace.